Hello everybody. Today we are going to talk about the properties of a rhombus. So a rhombus, by definition, is a four-sided quadrilateral with all congruent sides. We're going to tweak that definition a little bit. We are going to say it is a parallelogram. With four congruent sides. Now the reason we can kind of do that is because the definition of a rhombus says that all of the sides are congruent, and we know that if opposite sides, I'm going to even mark them, let's mark them congruent. And we know that if we have a four-sided figure, a quadrilateral, and that the opposite sides, both pairs of opposite sides are congruent, then it's a parallelogram. So we'll just kind of cut all that out, and we'll get right to the point that the rhombus is also a parallelogram, which means that it contains all the properties of a parallelogram, like the fact that the opposite sides are parallel. The definition of the parallelogram. The opposite sides are also congruent. All right, fine, we already took care of that. Now we could talk about the angles. The opposite angles of a parallelogram are congruent, so this entire angle and that entire angle. Same with the large angle at A and the large angle at C. We also know that the consecutive angles are supplementary. This angle, the large angle at B, and the large one at C, add them together, we get 180. Last property that we have for a parallelogram is that the diagonals bisect each other. So this diagonal is cut in half, and this other diagonal AC, that guy is also cut in half. So we can do this. So all of those properties exist for a rhombus too, but now the fact that we have all four sides congruent throws in a few more. So let's put that up here. All four sides are congruent. With that, hopefully you see that all of these little triangles are congruent. Can you remember how we can prove triangles congruent? Remember, there are 5 ways, and we can use one of those methods here to prove that all of these are congruent if we look at the markings. So side, side, side tells us that all of these are congruent, and since they are congruent, then all of the corresponding angles are also going to match. We already have the corresponding sides congruent, all the corresponding angles do. So all of the angles in between the 1 and the 2 sides here, I'm going to mark them once, because they must be congruent. On this side, we have a 1 and a 2, and those guys are congruent also. So now we see that this diagonal bisected that pair of opposite angles. Well, now I know also that the angle between the sides marked 1 and 3, 1 and 3, those guys are congruent. Here's 2 more. Between 1s and 3s, and they're congruent also. So this diagonal splits up these angles into 2 congruent pieces. Whereas the diagonals bisect opposite angles. Because what we end up with is 4 perfect congruent triangles. The last thing is that right here, we got something going on in the middle with these diagonals. Let's look at the two triangles on top. If these two triangles on top, on the left and the right, are congruent to each other, and DB is a straight line, and these two angles are congruent, well, if you have a straight line made up of two angles that are congruent, well, then they are right angles. So now I know that the diagonals are perpendicular to each other, and only in a rhombus, so far, only in a rhombus we can make this little perpendicular box in the middle. So these are the properties of a rhombus. All the ones we already knew, and all of these new guys. So we can probably guess that many of our questions and problems about rhombuses will center around these angles being the same and these diagonals being perpendicular, and of course all the sides being the same. So those are the kind of new problems that we're going to look for. Let's take a look at down here at the bottom, and let's see these last few questions that they are asking us. I think I'm going to take this out of my clipboard. Okay, so we have these down here, so now I have side AB. Well, all the way up at the top, I see that AB is congruent to all of the other sides. So that's what we're going to write in here. Is congruent to BC, and that's congruent to CD, and that's congruent to DA. AEB. Up here at the top, I have A, E, B, and we know that that's a right angle. That guy is, see how we're asking for M, the measure, that means a number, 90 degrees. DE. DE is this piece here. Well, what is that is equal to? That is equal to EB. Sometimes when we have an equal sign, we're asking for a specific number. Other times we're asking for another guy that's equal to it. AC is equal to, looks like segment addition postulate. Let's check it out. AC is equal to this piece plus this piece. AE plus EC. Let's write it in. Angle DAB is congruent to, well, let's figure that out. DAB, that's the large angle at A. Opposite the large angle at A is the large one at C. Now, of course, angle C, I'm referring to the large angle. There are three different angles. There's the large one, the guy on the left, the guy on the right. When you have several angles with the same vertex, you have to name it with three letters, and C is the middle letter. D, C, B is the angle they are looking for. D, C, B. Okay, so measure of angle ABD is 34. Let's find it. ABD. A, B, D. If that is 34, then I'll just read it while we're looking. Measure of angle DBC. DBC. What's this guy on this side? Well, that one is also going to be 34. If AD, one of the sides is 10, then the perimeter is 10 plus 10 plus 10 plus 10, 40. Measure of angle BCE. Let's come back up here. BCE. The other way is 25. Then what is the measure of angle DBC? DBC. Well, if that's 25 and that's 90, then that's the rest of what makes up our triangle of 180 degrees. So we can take 180 and subtract away the 90 and the 25, and we will get 65. There's my little hint. That guy's 90, remember? Okay. Good job on the front. Let's flip over on the back for page 2, and we are going to see again. If you didn't print these out, no biggie, just pause, copy them down. Okay. As soon as I know I have a rhombus, this is what I'm going to do every time. It's my quick go-to. Now I remember that I have 4 right triangles, and they are all congruent. As soon as you have one of these acute angles, you can write all of them in. Let's remember that these two here are congruent to each other, and these guys are the same as these guys that are opposite them. So that's 20 and that's 20. Well, now I have 3 little congruent four little congruent triangles, and I have 2 of the 3 angles. So 90, 20, what's left? 70. So all of these guys are 70s. Number 2. Pause and try number 2. If you did number 1 together, you can get number 2 all on your own. Moving on to number 3. Okay, so now we are back with right triangles. We did lots of work on right triangles, and we said, okay, there are lots of different ways to solve right triangles. We used the Pythagorean theorem, we used our special right triangles, we used trig, and if we were in the classroom, we'd be using a lot of those all over again. But we'll kind of take it light, and we're going to start here today. So now, we have a rhombus. Now they're telling us that AC, which is this diagonal, is 8. One thing I remember about the diagonal is that it's cut in half, right? So this piece up here is 4, and that piece down there is 4. DB is 6. Okay, not drawn to scale, but we're over that. This piece is 3, and that piece is 3. So now, knowing this, I want to find the length of each segment. I didn't give you a variable. I'm going to put x in here. But we have the 1, 2, 3, 4 segments. We want to find these other 4 segments. So that's each segment. Okay. The one thing that I remember and my first go-to when I did the top is that this is a right triangle. And in a right triangle, if I have 2 sides, the 2 legs that are 3 and 4, I can find the hypotenuse. And if you forget it, some of us already remember, we can always use Pythagorean theorem. 3 squared and 4 squared, because 3 and 4 are my legs, is equal to x squared. 9 and 16 gives me 25. Square root. And it's a 3, 4, 5 triangle. So each of these sides is 5. Using some of that, we're going to do number 4. This time they tell me I have a perimeter. The perimeter of this rhombus is 40. But we remember that each of the sides is the same, so each side is 10. They tell me that EB, this little piece here, is 8. I do know that this guy over here has to be 8 because it's bisected. The last piece of information I know, draw on those right angles, because the right triangles is the way we're going to solve many of these problems. So, blank, 8, 10. This is the last piece we want to know. And of course, if we find one, we know the other because they are congruent to each other. So this is x squared plus 8 squared is equal to 10 squared. Some of us may know this already. If you know your triples, write it in. You don't need to do all the work. Subtract 64 to the other side, and it's 36. Square root, x is equal to 6. It's a 3, 4, 5 times 2, 6, 8, 10. Good job on these. So there's another handout with practice. Go ahead and try those, and I'm going to make a video also in case you get stuck on those. I'll work through those with you too. So have a great day.